and welcome to our investor webinar. We are very, very excited to have you all here today and share about what we're building here at Episcore. My name is Anna Chen-Yun Tai, and I am a CEO and co-founder of Episcore. I'm here today with Trevor Ragnaw. He's the Director of Construction Technologies at Episcore. Hey, Trevor.
Hello.
Great. And we are basically the two constant hosts of our webinar. And if you're about to join Episcore as an investor or you already invested, you're going to see us pretty frequently. And we hosted like maybe 7 or 8 webinars so far. So it was a lot of fun and great questions. And we are really happy to be, available and share what we are doing at Episcore. So also, these webinars are basically to provide more information about the Episcore, the business that we build in, and technology, and also answer the questions. Also, we not really allowed to tell more about the hard numbers due to the hard regulations on Start Engine. And before we get started, I just want to give a brief disclaimer that in case anyone watching this is interested in investing through Start Engine, basically, the information we share with you today should not be used to make an investment decision. Again, there are a lot of strict regulations on how we present our company to potential investors, and especially around the financial projections, we are not allowed to share it. But we do have the financials, audited financials on the Start Engine page. It's all required by law. So today, the presentation is more informal. The presentation contains forward-looking statements and are based on the reasonable expectations, estimates, and projections that our company management has done so far. So please do not interrupt anything we say as a financial advice, and please refer to the Start Engine page and offer materials before you make the investment decision. Thank you so much. So that was really important information before we started, and now we're ready. So I hope that you're gonna see my screen now. Yep.
Got it.
Okay, yeah, this is part of the disclaimer just to show one more time again, because again, we're required to do that. Please, again, watch all of the documents on the Start Engine. So let's get started. I'm just checking all of the systems. Okay, perfect. So let's start from the beginning. Episcore, we are the construction technology company that's developing and manufacturing the construction robotic solutions for construction, specifically to how to build faster and lower cost, at lower cost. We are not the developer or home builder, but we provide the technology for the home builders so they can build faster, they can increase productivity, reduce the errors on the construction site. Basically, we believe that we have the right tool to empower the home builders and construction companies to really make better houses and build more houses that can be available for everyone who need housing. Why the construction companies really need that? So unfortunately, today there is a significant labor shortage, and home builders, they struggle to meet growing demand because of that problem. Specifically, home builders, they can have like 10, 15 people on site working today, but tomorrow nobody can show up, nobody can pick up the phone for many different reasons. Sometimes it's because the crew was offered a better pay, for example, on another project, or just received the much better work to do, like more houses, more order volume. So that all leads to the unpredictable and unexpected changes in the budget and timeline, and inconsistent quality. You also need to fix all of the errors, because it's still people coming in, and the first part of the house can be done by one crew, then you have another crew with the less experience, for example. So inconsistency in the quality is also the big factor for the for this problem that home builders are having today. And of course, the building a house can take a lot of time. It can be as long as 7 months, sometimes even more, sometimes faster. But the problem is that it's not really fixed time that all the time home builders can say like, okay, this is going to be my timeline, no matter what, it's going to be a constant. That's not happening today right now. What we offer as a solution, we introduce Frank. Frank, it's our construction 3D printer, our proprietary technology and robotic solution that we developed. Using the Frank, home builders can build walls 9 times faster, and finished houses can be done up to 3 times faster. And also it helped to save money and construction costs, and the buildings can be built up to 20% more affordably, but it all depends on the design and the location and everything, but still it can be a significant cost savings. And Frank is operated just by one person, by one operator versus 10, 15, or 5-person crew on site. And more importantly, Frank does not cancel the job. He's available every day, and he even can be available more than like 18 hours per day. So this availability and the reliance on the for the Frank is really the game changer for the construction companies, how to build better and faster. We also, it's not something that we just, this is the great technology, let's do this. We actually show the track record of the projects where we deployed Frank and its early versions to build real houses, test everything, learn the technology. And it was a really journey of how we improve the product and the technology before we start, releasing it to the market. So here you see the Frank. It's a 4th generation on one of our projects, basically set up. The white big building, it's something that we 3D printed in Dubai. This is 2-story, beautiful administrative building, almost 7,000 square feet of the living area. And the walls for this building was built just using single Frank, single 3D printer. On the left, you also see one of the projects we delivered here in the United States. That was completely finished house. So we learned how to use our technology, not just to 3D print the walls, but how to also integrate it to the overall construction project, so we can know everything about the entire project process of the construction with this technology. This is the snapshot of what kind of our journey looked like so far. We 3D printed really a first building. That was the most famous building, I would say, because that was the project of the house when we demonstrated that houses can be 3D printed directly on site. Before, the additive manufacturing, concrete additive manufacturing was used to 3D print the walls at the factory, then deliver them on the construction site and assemble together. So doing this first project, yellow round house, we demonstrated that now it can be done differently. It can be really 3D printed on site as a single piece without any extra assembly. Then we 3D printed this huge building in Dubai. It's today still Guinness World Records as the largest 3D printed building ever constructed on Earth. That project really was a huge learning curve for us, and I believe that we really learned a lot, and really unique experience that helped us to build a better product that we are really happy to offer on the market today. We also did 2 projects in the United States. One was just we 3D printed the walls for the residential house in Missouri, United States. And then, as I said, we 3D printed the walls, and we also completed the entire project, the entire building in Boca Chica, Texas. And also between the first yellow house and the Guinness World Record, we also participated in NASA competition, and we took all of the top awards at that 3D printed habitat challenge. That was more about how the autonomous construction 3D printing technologies can be someday used on Moon and Mars to 3D print shelters for first to arrive. And the task was to demonstrate how we really can just, hit the button and start printing without human intervention, because this is how it's going to look like in actual construction beyond Earth. We demonstrated the highest performance on that, and this is how we were able to the top awards on that competition. That was also a huge learning curve for us for the material science and how to actually make the technology really easy to use by everyone. Because we couldn't really go to the process and help the machine to do something. And that really caused us okay, we really need it on Earth as well, because the construction side is so complex. And if we introduce new technology, it has to help build much easier, not to create, more problems or create demand more skilled labor. So that participation in that competition was also a really important contribution in our technology development. And this is the picture of the Dubai project, Dubai building. So this 2-story building, and I just wanted to show this picture to demonstrate that just this one printer, Frank, it's like the early version of that, just single machine was used to 3D print such a big building. And this is something that also really separates us from all other 3D printers available on the market. And Trevor is going to tell more about that. But the main thing is that the envelope of the building that we can 3D print is really potentially has unlimited, infinite square footprint. And here you can see this is the building in Dubai that we 3D printed, the walls. This is the first floor. And here you can see how small the printer actually relatively to the envelope of the 3D printed building. We just moved the printer around the construction site, and this is how we were able to cover such a big 3D printing area. We could actually 3D printed even larger envelope of the building. Again, the possibilities is basically infinite. But this is the new Frank that we have right now. This Frank, as you can see, is mounted on the Caterpillar tracks. And compared to the building in Dubai that we 3D printed using that Frank, now the modern Frank is much easier to operate, to transport and deploy, because before we used crane just to move the Frank around the construction site. And we learned that it's not the best solution how to do this. So how we can really have equipment that really requires minimum labor and minimum vehicles and all of the tools to handle it on the construction site. So today we just use joystick and laptop and the iPad just to move the printer around the construction site. This is one of the projects that we did in the United States. And when we tested all of the systems, all of the new systems that we developed and incorporated in the Frank after our experience on the previous projects. And I know that a lot of people have questions about the 3D print material. During this journey of the product development, testing, and all of the pilot projects, we also spend a lot of time how to create the material. The material that we use today, it's basically concrete mortar. But it's even stronger than concrete blocks, and it's perfectly, work for the extrusion process, I would say, because we cannot use the regular concrete. Regular concrete is just the puddle. You cannot really form the layers or any shape of it. With the 3D printing for construction, we need to have the material that's durable, strong, but also have some specific characteristics so we can actually 3D print the walls. We successfully managed to do this really advanced project material. And if you ever see our 3D printed walls, you can really understand that material is really advanced, and we spend a lot of time how to figure out the perfect formula for that. And as I said, we are not just even the robotics company, we are the construction technology company. That means that we create all of the solutions around this innovative technology. And it's not just robots. It's also the materials, and it's also the engineering systems for the 3D printed buildings. How the 3D printed buildings can be permitted, can be can have all of the required characteristics for the building performance and everything. So we also spend a lot of time and efforts how to create the engineering systems for the 3D printed walls that can be easily integrated in the construction process and can be accepted by the building permits and regulations. Also, Frank, it's not the only star in our robotics line, I would say. We also have, Frank has the little brother, we call it Gary. So Gary, it's a mixer and pump, and we created Gary after our experience in Dubai. So when we 3D printed the building in Dubai, we used just regular solution available on the market. It was actually just for the plaster in the walls. It was not for the 3D printed the walls. And that was a really like a nightmare, honestly. And we extruded a lot of material to 3D print the building in Dubai. It's actually the material we extruded there would be enough to 3D print like a 10 or 12 single family houses here in the United States. So, and using that market available solution back then, we all the time needed to stop like at 2-3 hours just to clean the machine. And it was all of the clogging. We manually needed to add water, and somebody has to constantly supervise the machine. So we completed the building in Dubai using that machine, but then we just like, if we really want to scale this technology and have our customers be happy to use this technology, we cannot continue using that plastering machine. We need to develop and build the specialized equipment for that, specifically for the 3D printing technology. So this is how Gary actually basically was born. Gary was already successfully tested and deployed on all of the projects here in the United States. And this summer, we're going to release Gary 2.0. It's going to be like a way advanced Gary. We're really excited about that. And it's actually going to look like even better and with a lot of improvements. And now it's like such a pleasure to work with Gary. And it's really like we got to the point when we really can have one person to operate Gary and Frank on the construction side. So we're really, really excited about our product presentation this summer, and we're gonna share a lot about all of the improvements we've done so far. And I would say that the really important stuff is that Gary and Frank can fit just the trailer, standard flatbed trailer, and it can be transported by pickup truck, like a F2500 or like a Dodge Ram 2500. And it's again, one person to transport, one person to deploy, and one person to operate the entire machinery needed to 3D print houses. And this is something that not really available by other companies, gantry printers or the industrial robots, for example. We worked really hard how to not just to create the technology that's easy to operate, but what would be the unit economic behind this technology so it does not create more costs to use this fancy technology, right? Because sometimes companies create something and they think like, oh, it's so cool, it's so fancy. Yes, you can use it, but it doesn't mean that you should use it. In the construction, numbers are really, really important. And if we introduce new technology, it has to be more affordable compared to the existing modern technologies or approaches how we build houses. We cannot create more costs by introducing this technology. We have to reduce them. So I just want, to bring this to the attention that pickup truck and trailer, it's important part how to really reduce the logistic costs for this robotic solution for the construction process. And if we talk about the other solutions, and again, Trevor will cover it in more details. Now you see that our printer is basically just pickup truck and trailer, one person to operate. If you look at the other, like for example, gantry printers, they're most popular alternatives today in the market. It can take like a 2 or 3 18-wheelers just to transport the gantry printer. Then it's like 10 people and like 10 days just to assemble it on the construction site. And you need to do this every time you build new house. So this is huge logistic costs and operational costs. So we just don't believe that it's really the route when this innovative technology or like this disruption of the construction industry should actually follow, because it just economically wise doesn't make sense. And as a proof that we are not the only who say this about our tech, we have a lot of home builders that are eager to use our tech. We're already making sales. We started the commercial launch in January this year, and we having the first sales, and we also have the prepaid orders for franks. It's right now it's more than 20 franks already reserved, and we expect that during the product presentation this July or August or even earlier, we're going to convert most of this in the sales, or maybe all of them, because the customers and the home builders are really, really eager and excited when they see how compact and easy and to use the printers that we have. They visiting us constantly in our headquarters in Melbourne, Florida, so they can see really how our tech and product compared to the, for example, gantry printers, and they really fascinated. So they just right now waiting to to put all the funds together and coming back to place the order. But more importantly, our business model is not just sell the printers. We actually pursue to have the business model razors and blades / HP, I would say. So we actually make most of our revenue and recurring revenue on the 3D print material. So even this customers and sales pipeline, it's already present the booked revenue or like a revenue potential for more than $40 million just on the 3D print material. And it's going to be recurring revenue. And what is really fascinating is that we're able to create the business model with the recurring revenue in the industry when this type of business model never existed. Nobody can really make the recurring revenue in the construction industry. So with this new tech, we actually can not only transform the way how we build houses, but it's also going to be the new business model and basically new industry, I would say. And here more about our razors and blades business model. Conservatively, eventually we want to lease or like rent out the printers and exclusively supply our 3D print material. And it also needed to make sure that the printers works consistently and without any damage, and that the 3D printed walls, the end product, is also going to be in compliance with the building codes, going to have all of the structural characteristics as needed. So basically the end product is also safe to live in. And conservatively, our goal within the next 4 or 5 years is to have 400 printers, 400 franks in operation. This amount of franks, they will be potentially able to extrude amount of material that equal to build 20,000 homes annually. And that basically will require like billions of pounds of the material to deliver this numbers of houses. And this is where we're actually going to create the recurrent revenue. As estimated, it can be as high as almost $300 million. And again, this is the plan to achieve within the 4 or 5 years. And about the market, so we calculated the market specifically for our business model, and the opportunity is really exciting. For example, it's 3 segments of the market that we can go after, that we're actually going after. Low-rise residential, single-family housing. We just, took all of the numbers of houses built annually in the United States and calculated, okay, if all of these houses would be 3D printed, how much material we would sell for this. So it's more than $20 billion just for the market for the low-rise residential single-family houses. But because our tech can 3D print houses of unlimited square footprint, as I already said, we also have access to the commercial construction market. It's less because it's like not so many commercial construction happening, but even though it's more than $7 billion just on the commercial construction and equipment rental. So let's say all of the home builders, it's estimate like approximately 500,000 of home builders in the United States. If they rent the machine every year or like every month, because we're gonna do annual rent or like a month-to-month rent. So, but anyway, recurrently every year it's going to be more than $50 billion. So this is how we specifically calculated the market opportunity, market size for our business model. And I know that the eco-friendly construction, or like how we can use different or alternative materials, it's also the frequently asked question. So we have three components how we can contribute into the more eco-friendly construction in the future. First is the alternative materials without cement at all. And there is already the material that can be a very good option for that, and we already tested it in the past. It's a geopolymer. And geopolymer, it's not plastic. It's actually looks like concrete, but without cement as a binder. And geopolymer materials, they actually already been used in the construction before. The airports in Australia and Europe, they were built using geopolymer, and today it's actually getting more and more attention and applications in the modern industry. So we didn't really invented it, but we tweaked it a little bit for our process and, you know, make it more cost effective so we can actually use it. And second factor, that we can reduce the carbon emissions from the transportation, specifically because two Marys, actually bulk truck that you see right now, it's also part of our material delivery system. We call it Mary. So the entire family, it's Frank, Gary, and Mary. So Mary delivers the material to the construction site. And we need basically two Marys, or like two bulk trucks, to 3D print standard 2,300 square feet house, the walls, I mean. Compared to the traditional construction, it's going to be way more trucks to deliver all of the materials, and a lot of waste generated from the packaging, from the leftovers and everything. So we can also contribute in this aspect of the eco-friendly construction. And of course, it's the reduction of the construction waste. Typically, it's like 8,000 pounds of the construction waste generated per single family home. It's not only walls, it's all of the roof, windows, everything. It's basically, it's packing materials, leftovers, pallets, everything like that. And dry walls, it's also a big part of that, because you have all of the cuts and leftovers when you build the drywall. But we're going to install the insulation just in the 3D printed wall. There is no packaging at all. You just inject the foam, and Trevor also will cover more of this in the details. Here's more about the geopolymer. So you can see that it's not plastic. It actually looks like concrete, and we already tested it. And geopolymer already used for the slabs, for example. Here more about the reduction of the construction waste and carbon emissions that I just covered a second ago. So if you look at how to build walls with the concrete block construction, you actually need about like 40 pallets with the concrete blocks delivered to the construction site. And then you need like 88 bags of mortar also delivered on the construction site on the pallets. So, and you also need to have the forklift on the construction site. Then you have a lot of waste. Then you also need another truck to remove it from the construction site. So in total, it can be like 6 trucks, including 18-wheelers, couple of 18-wheelers, constantly traveling to the construction site and generating all of the carbon emissions. Compared to our process, it's only 2 bulk trucks to deliver all of the material to 3D print the walls, and 1 pickup truck to deliver the actual 3D printer. Once you 3D print the walls, you don't have all of the waste, all of the pellets bags and leftovers, concrete leftovers, so you don't need to have another truck just to remove the waste. So I think this is really, really awesome, and additive manufacturing really has a huge potential to contribute to the reduction of the construction waste, and this is basically we see how. Now I'm just already wrapping up. So that was kind of short about what we're doing and what we achieved so far. But this webinar is basically to help potential investors to, learn more about our technology and then learn more about the investment opportunity on Start Engine. But this is what we achieved so far in Start Engine. We already raised $1.2 million on Start Engine from more than 1,000 investors. This is really, really exciting for us because having this public endorsement, it really means a lot for us. That so many people really believe in what we do, our vision, and many of them that we met in person then say like, oh, it looks like you're doing it right. And it's really, really means a lot for us. And if you invest on the Start Engine, there are also investor perks. Depending on how much you invest, you can get the online courses. Online courses, it's something that we created to tell more about the technology and industry in general. And we have almost 1,000 people so far enrolled for the last 2 years. And Trevor Rugno is the best ever professor that I met for the online courses. People really love this product because they can learn more about this emerging technology. We shared a lot of our knowledge, practical knowledge that we gained about this industry and tech. So you can receive the online courses. And also, if you invest the specific amount, you can visit the live printing or even stay for a night in the 3D printed houses we're going to print this year. And just last word about the plan for this year, the 3D printed houses. We're going to have model house built on Space Coast this summer. Basically, the building permitting process right now on the way. And this is where we're going to invite our investors to see live printing. If you cannot make it on this particular project, we're going to have more projects across the country this year where you can come and see the printer in operation. It's even going to be 2-story building in Texas. And we also have projects in Louisiana, California, and Alabama, and more coming constantly, new opportunities. So it's going to be a lot of projects this year that we're really excited about, where we're going to demonstrate all of the new Gary, new Frank, and everything we achieved so far. Yeah, so that was everything that I wanted to share. And now I'm going to pass it to Trevor and also going to answer some questions while he is presenting. Thank you.
Excellent. Yeah, thanks so much for the presentation, Anna. I will go ahead and share my screen here. Now, I'm Trevor Rugno. I'm the Director of Construction and Building Technologies at APISCore. My background is really in commercial construction. So I've done offices, apartments, multifamily, self-storage, kind of a lot of kind of a wide range of construction activities, even prior to working with APISCore. And I already mentioned some of these things on the screen, some of these things that our company's done. Also a great patent portfolio. Just wanted to point that out. So some people here may be familiar with traditional construction, but just to make sure we cover our bases, let's kind of compare and contrast the two. With traditional construction, there's a fair amount of human error, and that human error is pretty costly. Average of 10 to 25% of project costs with traditional construction are right now due to human error. Obviously, with a robot doing it, you're sure that your walls are always going to be plumb, level, and square. So, for example, if they weren't with a traditional building, well, that's going to affect how your flooring goes in, and your baseboards, and your drywall, and your cabinets. So making sure that primary structure is spot on really helps to streamline the entire construction process and reduce costs and reduce that chance of human error. When it comes to the actual material, once the printer leaves the site and the people leave and, a family moves into a home, what are you left with? You want to have something that's really durable, can withstand the elements. We're here in Florida. We deal with hurricanes and flooding, and concrete is the gold standard for construction, especially concrete blocks. And when we see some of these wood-framed homes all across the nation, we're seeing them becoming susceptible in places like California to fire and to water and to mildew and pests. It's essentially a flammable absorbent termite food that people are building with. So being able to help make more resilient, more longer lasting homes is something that's important to us. And as Anna mentioned, when it comes to scheduling, it's one thing to be faster, but it's another thing also to reduce the risk of going way over schedule when you're out there building a home. You want to make sure that you're delivering these things on time. And before we ever step foot on a construction site, we know down to the second how long that home is going to take to print. So this helps with everything from small scale construction up to large community development when you're trying to project, okay, how long is this going to take to deliver? Anna touched on this. Construction and demolition waste is the single largest contributor to landfills. It more than doubles all other municipal solid waste combined. And now we're able to bring in this technology that's zero waste. It's all electric, and the mortar, the rebar, all the things that go into our walls are fully recyclable. So this can help create more of that circular economy. Now, one of my favorite things here is the design freedom that you get with this. We're used to building with straight lines and hard corners because, that's how the materials come, the blocks and the sheets of plywood and the 2x4s. It's easy to manually assemble corners, and that's why we see them a lot in our buildings, but there's no straight lines in nature. Now we're able to build a curved wall that would typically cost significantly more than a straight wall of building traditionally. We can do that at the same price or sometimes even less because you're literally cutting the corner. I think that we really believe that this ability to create more unique shapes at the same cost is going to inspire architects to usher in this new era of architectural freedom. And it's something we're really excited to see. So this is all going to be recorded. I know there's a lot of information on this slide and the next, but essentially these are some of the specifications on Frank, the 3D printer, and on Gary, the mixing system. Now, Frank gets all the glory, but Gary in reality is kind of the brains of this operation. Unlike most printers that use these plastering machines, and they don't really communicate well with the printer, there's a lot of issues with consistent delivery. And at the end of the day, the printer is only as good as the material that it's receiving. With Gary, the mixer constantly communicating with Frank and Mary, the Volk truck, it's able to manage the material and manage the printing process to make sure everything's working in sync and in harmony. And at the end of the day, that's the reason why our 3D printed walls have this kind of unmatched quality that you don't see anywhere else in the industry. The mixer is kind of the secret ingredient to this whole family here. So, here's Frank. Of course, self-driving. Here you have a joystick control. And you'll see a lot of really great video online of this printing. And it's not just curved walls. You can get really sharp corners like this, great lines. And, we're going to talk about control joints in a minute, but basically those sections combine really well. This is exactly how it looks coming out of the printer. And the better the quality that comes out of the printer, the easier it is to get a delivered house. This is essentially ready to paint and deliver here. So we know the difference now between traditional construction and 3D printed, but what about, other printers versus the OptiScore printer? Anna touched on the transportation point pretty thoroughly, so I won't harp on that. But essentially, it doesn't take a mathematician to understand that it's more affordable to transport with a truck and trailer than a semi-truck or multiple semi-trucks. In terms of setup, our machine comes fully assembled. You drive it off the trailer, and a single person can set this printer up and begin printing in as little as 30 minutes. It's not a 3-day, 10-day, 14-day setup time to get this printer out and operational like some of the others. autonomy here. Again, we already have this kind of ecosystem where the printer, the mixer, and the bulk truck are all working in harmony. So it doesn't take these large crews that you see on other 3D printing construction sites to monitor all these individual components. They're largely monitoring themselves, and that helps streamline our build process. And lastly here, the build area. With those gantry printers, it's almost like a desktop 3D printer or a CNC machine, but put on steroids, a massive machine. But despite their massive size, you can only print inside the box. So the bigger the home, the bigger the printer. That's not a limitation that we have, and it allows customers, regardless of if they're making tiny homes or Guinness World Record setting buildings, they can still use the same machine to do all those jobs. So let's talk about that printing in multiple sections, how we make those massive homes. So you can see here a printer will print section 1 and then move over to section 2 and begin printing. Where those two sections combine is called a control joint or an abutment. These are something that are required by building code, these building movement joints. And normally you see masons out there with a big cement saw. They're holding it over their head and they're cutting this control joint into the wall. We don't have to do anything like that because the printer's automatically doing it. So it makes the construction site a safer and easier place to work. Also, during this process, while the printer's operating, we're installing things as a printer operator like, outlets or insulation or window bucks and frames and a lot of these secondary construction activities that typically have to wait until after the masons leave the site. It's these overlapping concurrent activities that help us accelerate the overall construction timeline. And lastly here, our current printers are able to print using multiple printers, even on a single home. So we can scale and deploy the technology really effectively. Let me show you what that looks like. So here in the top left corner, you can see two printers that are printing at the same time in the same building. And in the bottom right now coming in, we can see multiple printers that are building multiple houses. This just shows that if you're a tract developer, if you're one of the large home builders, you can still use this technology just as well as a smaller operation that is building more custom homes. So this is, honestly, the secret to our success, especially when it comes to permitting and design and our ability to really deliver projects. A lot of companies want to reinvent the wall, but to us, we really just see that there's already a gold standard out there, the concrete masonry unit. These blocks are made by machines and then manually assembled by people. But if we could use our machine to make those exact same concrete block walls, but significantly faster, stronger, and at a fraction of the cost, then that makes a lot more sense to us. And this allows us to follow the existing building code, not create some new complex building code. So let me show you what that looks like here. On the left side, there's a standard concrete block wall. You'll notice that there are these wall cavities, which both walls have, some reinforcement, which both walls have and in the exact same places, and things like ladder wire and a bond beam. These are all things that a traditional concrete block home has that we just mimic with our 3D printer. That means you don't really have to retrain your architect to learn how to build a 3D printed home. You could very easily convert a set of drawings for a concrete block home into a set of drawings for a 3D printed home. If you're not familiar with the difference between the drawings, on the right here, this is technically for a 3D printed home, but it looks very similar to a concrete block wall. I mean, really, the only difference is this little annotation that says, it's a 12-inch extruded concrete wall instead of a 12-inch concrete block wall. Other than that, they're essentially identical. That's the reason why we've been able to demonstrate compliance with things like the International Building Code and with standards for concrete masonry unit construction. All of this stuff is published on the NFPA's website. So if you have more questions about some of those third-party engineering tests or standards or permitting, you can definitely go ahead and check that out online. And in terms of design, this is another question we get quite a bit. How do I design these structures? And again, it's very easy. We have a plugin that we've created for both AutoCAD and Revit, the two most popular softwares used by architects and engineers, that really allows them to, in minutes, create G-code that is the printer's native language. Frank doesn't speak English. He speaks geometric code or G-code. So the architects are now able to seamlessly work into their existing workflow, designing these homes, and then even testing them using our simulator. That way you can test out the G-code before ever going out into the field, and you know that when you do go out there, it's going to be a success. Of course, this is something our customers can do, but we also offer services to create G-code for them as well. We get a lot of questions on secondary construction, things like, how do I add a roof to this building, or install windows or reinforcement, or, how do I do these other things? And, thankfully, the answer to every single one of those questions is you do it the exact same way as you would for a concrete block home in your area. So we're following the existing building codes. If you were to take a concrete block, and like you see in the picture on the bottom right here, if you were to set that concrete block on top of our wall, everything matches up perfectly. The webs in the middle, the reinforcement, the thickness of the walls. This is a real benefit, not just from the design side, but when you have a window installer come in, these walls are familiar. They can look at them and go, oh yeah, I know how to put a window in that, or yeah, I understand how to put a roof on that. It's because it's identical to the gold standard that's already available. I know that there's probably a lot of questions here, and we don't have much time today, but we do have a lot of resources available online. So if you're interested in learning more, I'd definitely recommend checking out OptiScore University and checking out some of the information we have on our Start Engine page. So that's it for my presentation here. I'm going to go ahead and pass it back to Anna, and we'll see if we can get some of your questions answered. Thanks so much, everybody.
Thank you, Trevor. That was awesome, as always. So I think there are two questions that you can address. Please detail reinforcement and load limits. But I think we covered this during the...
Yeah. I mean, if they're asking specifically that, there's things like, you follow your local code. So some places it's different than others if there's seismic activity or, very high winds or things of that nature. But typically you'll see reinforcement for 8-inch walls every 2 to 4 feet off center. And for the 12-inch walls, you see it every 6 to 8 feet off center. It's normal number 5 rebar grouted with concrete. So yeah, again, it's nothing that is outside of the standards for traditional concrete block construction.
Yep. Yeah, and that was actually the entire idea behind designing this concrete block-like 3D printed pattern, because 3D printing technology allows to great flexibility. You can 3D print any infill. Somebody prints like the zigzag, for example, inside, right? And you can print 8-inch wall, you can print 12-inch wall. So we realized that, yeah, that's great that you can do whatever you want, but building codes are not about that. They really about the standards and like a one uniform that then everybody can like look at the building codes and say like, oh, okay, this match this. Okay, this is how we're going to handle this. And we specifically, designed this concrete masonry unit like pattern, because in this case, we 3D print the same wall structure of the wall all the time, which are the same as concrete block construction. And that means that we can apply all of the practices that already applied and permitted for the concrete block construction, something that exists. In this case, we can really make it much simpler for all of the building permitting, and also how the architects and engineers can actually design the houses. They like, oh, okay, I just need to do everything the same as for the concrete block construction. And as Trevor said, it's just the walls a little bit with this sausage pattern just on the drawings. That's the only difference. Yeah, and maybe Trevor, you also can touch on the why three-story limit.
Yeah, great question. So essentially with concrete block construction, there's generally limits that are imposed, and these are can be on the state level, on the county level, on the city level. And oftentimes for 8-inch walls, your limit is 3 stories, and for 12-inch walls, it can be sometimes 5. We're really showing this limit mainly because that building in Dubai was about 32 feet tall. That equates to about a 3-story building. So we've already tested this up to 3 stories. We know that works. That doesn't necessarily mean that it isn't possible for the technology to build higher. And you'll definitely see other commercial buildings in particular that will have kind of post and beam construction, where you'll see these big concrete columns that form the primary structure. They're transferring the load down to the slab, but there's also concrete blocks that are filling in between all of these. So, in the future, we'll definitely see, I think, larger and higher 3D printed construction, but we don't want to necessarily oversell the technology or tell other people to go out there and do something that we haven't done ourselves. We've done this, we know how to do it. We're letting people go ahead and be really successful with this technology, doing things that we all know you can do. Will that change in the future? Maybe. Of course, we see technology constantly improving and evolving, but at least for now, we want to make sure that we're speaking conservatively and we're able to support our customers with our extensive base of knowledge.
Oh, yeah, I absolutely agree. And also about the high level or like the multi-story buildings, it's also that if you go more than 3-story, like higher than 3-story, it's like a different type of construction. As you see all of the tall buildings, first the skeleton basically build with all of the reinforced concrete, a lot of rebar and everything. And then the concrete blocks or in like other prefabricated panels used just as a self-bearing walls, for example, just as just to fill this voids in the skeleton. So it's completely different construction approach, I would say. We don't know how to really fit this, especially our robots, in that process of the tall buildings. It's really different. And even if it's possible, the main question that we need to answer first, is it really better economically wise, or is just fancy cool process how to do this, and you need to pay more, and it's like it completely doesn't make sense. So we are not going to do something that does not benefit the industry or users money wise, or like economically wise, and even like the operational wise. Again, if we can do something, it does not mean that we should. And also the another thing about the tall buildings is that we have Frank and we have Gary. So if as you go higher, you also need to bring Gary higher. So you need to also bring the material higher. Otherwise, it's like a long trip to pump the material. That might be all of the other technological challenges. So it's just really different, I would say, with the tall buildings. And again, we know how to build single-family houses, how to apply this technology for single-family houses. Huge market, huge need. We want to first really focus on that, be successful, and then see if we need to really expand to the other applications. Oh yeah, the another question, I saw a picture with what looked like a 3D printed floor. Are you able to do this now? This technology or like a concept it's still in the research and development and product development. We tested it, yeah, we can do this, but we still don't know if it's going to be a really good fit, like integrated in the current process. Recently, we just see that even with the wall construction process, we can really bring a lot of benefits and save a lot of money, even like with the insulation, with the painting, and how we do the electrical plumbing. So we really want to find the real problem and solve it. With the printing the floors, we we tested it, it works, but we want to make sure that it's really going to be a need for that, and we want to figure out how to successfully incorporate it. So yes, we can do this. Still, we can do this, but we did not start the commercialization of that yet. And Trevor, are you in a printed building now?
Well, my virtual background is inside the Dubai building. So yes, I guess I'm by proxy. I'm here in Melbourne, Florida right now, but the background is, yes, one of the rooms that we've 3D printed. Really beautiful structure.
Yep. That's the one of the room of the building that we 3D printed in Dubai. So that's virtually Trevor is there. Another question about the building codes. I think that if you can also briefly touch it again, that would be awesome. How would we prove local authorities that 3D printed walls would be the same exact thing as CMU blocks? Is there certificates we can present to them?
Yeah, great question. So kind of the best document to present is the APIS Corps' kind of NFPA publication. So if you were to Google like APIS Corps, NFPA, the National Fire Protection Association, honestly, most building codes are built around fire. The reason why doors need to be a certain width, it's for egress, or why certain materials like drywall are used inside. It's because, half-inch gypsum has a 30-minute fire rating, or ceiling or electrical. That almost it's amazing how many things in construction are drawn back to fire code. Of course, concrete isn't flammable, so that really gave us some great points with the NFPA. But when they published these third-party engineering tests that showed the IBC compliance and showed the National Concrete Masonry Association compliance, and showed that this is all of the engineered stamp documentation that proves this is it meets or exceeds all of the standards for concrete masonry unit construction, that is the document to present. So we always show that to building officials. And so far, we've never really had any pushback. And we have a lot of people that are working with us, people in the online courses, people that we speak with. And from what we hear from them, they've had great experiences with building officials because of this document and our kind of explanation that it's to a building official, it's a concrete block robot. It's, to them, 3D printing, okay, it's cool, but what is it doing? It's making concrete block walls, great. And, this is why we were able to create the first commercially permitted 3D printed building in America. Other companies aren't doing this concrete block pattern, partially because it's not as easy as it sounds. When you have a really large printer that's making all those very quick back and forth movements to create that infill pattern, those massive gantry printers, it's a lot of weight to be throwing around. Inertia, the physics is against them. We have a really lightweight machine that's very agile and allows us to make that concrete block pattern very quickly and very precisely. So, unlike a lot of the other companies, we're able to adhere to those existing codes and do it very consistently, even more consistently than a block mason would be able to put together those concrete blocks.
Yep. Thank you, Trevor. So interesting question. So thank you, Anna and Trevor. For both of you, if there were any one or two things that keep you up at night regarding the future of APIS Corps, what would they be? You first or I first?
Man, how many sites I'm going to be traveling around to be? No. As somebody who's come from the traditional construction industry, there's a lot that you're constantly doing out on the construction site to just be putting out fires when you're working with traditional buildings. I'm not even necessarily saying literal fires. I'm just there's so much infield engineering and so much that you're trying to do to, just fix mistakes and compensate for not having the labor there that you need. And the biggest thing here that that just is keeping me up is that I know this technology works. I've used it personally, I've built with it, and we just need to be able to get more machines out there. The technology works, it's accepted, it's easy to use. We didn't come out here and just sell some dream without proving anything. We built the machine, we tested the machine, we did, we're on our fourth version of this machine, and now we need to scale it. So, I mean, if there's something that really keeps me up at night, it's that we just really want to be able to build more of these and get them deployed, because the demand's overwhelming. And right now we're just all itching to be raising funds and ramping up manufacturing. And, today we have people over here working with some new lathes and CNC machines, and it's great to see it happening. But, now that we've come this far, I love seeing the fuel getting thrown on that fire to help, push this effort even faster and even further.
Yeah, and it's like pretty the same as I would say. If you ever saw how the construction process, happening, a lot of the materials, a lot of everything, people, it's so almost zero efficiency, and it's really like I don't know, it's something that I really believe it can be fixed. And because I studied space physics, and it's like all the time about math and physics and how everything can be really efficient and like optimized. And when I see anything that like really done in a stupid way, I was like, it can be better if you use the technology and machinery. And like just the idea that this process where like 10-15 people lifting really heavy blocks and then apply the mortar, and then it's like a bunch of forklifts and all of the trucks coming in. I was like, it's so outdated. It's like it should not be happening. And then you see how the wall just can be 3D printed using one printer, and that's it. And the entire structure like come up, like rise up within the like hours. I was like, this is really sorry. My mom is calling me, sorry. And it's really like, it's so, so fascinating. And I think that's something that really keep me at night, like thinking about the future of EpiScore, how many efficiency and optimization we really can bring to this world. And instead of having people doing all of this hard physical work, now we can have more people in the construction industry, young generation, to operate the printer. Because today, all of the young generation, they're like, I don't want to do this really heavy work on the construction site, mixing the concrete. What? I'm going to go to, develop the software, working on the software company. But I believe that if we all go into do all of this software job, I don't think that our future going to look really bright. We really need to spend more time and efforts on the building physical world, because it's really something that can save us in the future. So I really just about the optimization and efficiency. And it's really fascinating how our technology evolved so far and really can bring this. So yeah, we're just really efficient people and advocating for efficiency. Okay, and the another question is, where do the parts come from to build Frank and Gehry? Are there any supply chain issues? So most of the parts we actually source here in the United States, and that was one of the another really a lot of part of efforts, how to design the printer that does not require the really long lead or special parts and hardware, for example, that you can source only in one country. So we actually designed the printer that a lot of parts, most of the parts, they available on the shelf in the United States. We have a couple of the suppliers from Europe, Japan, and Taiwan, but it's not for really this highly sophisticated parts or like a hardware. So they also like pretty readily available. And we also have the stock of the parts, spare parts. So in case something happens with the printer on the site, we already have this part readily available to change. And a lot of parts, they CNC machined, and we produce a lot of parts in-house. And part of this fundraising is also how to expand manufacturing capabilities so we can produce more parts in-house, basically to really significantly reduce cost to build the Frank and Gehry. have better quality of this parts and significantly reduce the lead time. So yeah, answering the question, I would say that we try to have all of the parts sourced from the United States, and so far we didn't see a lot of chain issues. In the past we had, so this is why we switched to another more common parts.
One thing to add to this as well that people love to hear is that there's actually a lot of components, over 100 components that go into the printer. They're actually 3D printed. So we have even plastic 3D printers that are running here around the clock that are manufacturing a lot of these pieces for the printer themselves. So it's kind of inception, 3D printers making the 3D printers, but it's actually a really great way to ensure supply chain resiliency and allow us to help make even minor incremental improvements over time without having to create a whole new manufacturing line to do it. It's something that we've seen really efficiently helping us to produce these printers.
Yep, exactly. And will you require venture capital going forward? Yes, we actually just recently started our next round of fundraising with the venture capital and capital firms, and also talking with a couple of strategic investors. They actually in the home building industry, and some of them are actually the national home builders. So yeah, we expect that we would like, of course, to have more investment, and we're working on that. We just want to make sure that we have the right investor, and the investor who also will help us scale and grow the business. So the answer is yes, and we're working on it. When are you coming to Nashville? So that depends when we're going to have the first users of the printers there. We probably going to have one of the company operating in Memphis, Tennessee. Nashville is Tennessee, right? I believe so.
Yes.
Yeah. So we don't have any home builder yet in Nashville specifically, but because we already making sales and we expect even more companies coming in, placing the orders after our product demonstration this summer, there might be companies in Nashville. Because again, we don't build houses. We are not the home builder, but we provide our technology for the home builders. So once there is a home builder using our technology in Nashville, so this is basically when we're going to be there. Where are your printers built? In the United States. Again, most of the parts we source and manufacture here in the United States, some of them coming from other countries, but the final assembly, quality control, engineering, design, all the testing, integration, all happens here in the United States in our main and only location in Melbourne, Florida. It's a Space Coast. Are you working on the roof systems as well? Not as of now. We just use the standard roofing system that already were used for the concrete block construction. As Trevor said, the walls are structurally the same as concrete block walls. That means that all of the other elements of the house are the same. How are you protecting your technology? What is the place to make sure foreign companies do not steal your technology? So we have 4 issued patents, a bunch of the patent applications coming in. And, you never be protected from to be copied, right? It's like, of course, it may happen. But the question is, even if it's copied, what would be the cost to build that printer, right? If it can look the same, but they will not figure out what parts to use, because again, like our IP or like the know-how, it's not just how the printer design and look like, it's also the manufacturing process and all of the mechatronics and mechanical solutions that we incorporate in that. Because again, when we create the printer, we also created to have the lowest cost how to manufacture it on the mass scale. And also another question is like a mass scale and mass production. we all know that not a lot of companies actually historically succeed with when they actually need to ramp up the manufacturing process. So it's not only just to copy the technology, it's also all of the execution, scaling, growing, what the technical support you provide, the educational support you provide. It's like the entire business itself. So we really fight for the best customer experience. And as long as our customers are happy, even somebody copied us, that's going to be another battle in the business arena, I would say. Yeah, so it looks like that we answered all of the questions. And I think we can wrap it up.
Excellent. Yeah,
Okay.
yeah. I guess thank everybody for coming here today and listening to this presentation. Again, we have a lot of information available online. I definitely recommend checking out that Start Engine page and OptiScore University and some of the other stuff that we have to offer. And keep an eye out for other announcements and for recording of this webinar after we close up here today.
Yeah, thank you all. And we will send all of the links for the Start Engine, for the online courses. So just keep an eye on your emails today. And thank you again for joining us. And we are really excited to keep working hard. Thanks.
Absolutely. Thanks, everybody. Have a great rest of your day.
Bye.